Good day, everyone. I'm Arvin S. Enriquez, your subject teacher in General Mathematics. With this video lesson, we're going to discuss the topic, the domain and range of irrational functions under your General Mathematics from Quarter 1, Module 8. Our lesson objectives. At the end of this video lesson, you are expected to first, define domain and range. And second, find the domain and range of a rational function. Now let's talk about what is a domain and a range. So when we say domain, so this domain of a function is the set of all values that the variable x can take. So these are x values. So while the range of a function is the set of all values that y or f of x can take. So there is a statement here that y or f of x because we can replace f of x using your y. Here, your domain is your independent variable while your range is your dependent variable. So the values of range will always be dependent on the values that we're going to put as a value of your x variable or domain. That's why your domain is an independent variable and your range is your dependent variable. So you need to take note of that, no? Again, whatever the value of your y or your f of x, since we use your y to replace f of x, then the values of these will be dependent on the values of your domain. That's why your y value or f of x or your range will always be dependent on the value that we're going to put as a value of your x variable or your domain. So for example number 1, we're asked to find the domain and range of a rational function. First thing to do is to check if this is a rational function. So check your numerator and check your denominator. If they are both polynomials, then the given is a rational function. So we need to neglect a value of x that will make your denominator equal to 0, and that is equal to 0. No? When your x is equal to 0, it make your denominator equal to 0. That's why first we equate the denominator x squared is equal to 0. Therefore, x is equal to 0. So we're just simply taking the square root of both sides of this equation here, no? That's why it becomes x is equal to 0. The square root of x is x, square root of 0 is 0. So the domain here, or your x values, is x, your x now. X is an element of all real numbers. So when we say x is an element of all real numbers, meaning to say these are positive and negative numbers, including 0. But in this case, since 0 will make your denominator equal to 0, once we substitute this 0 to your variable x in your denominator x squared, it makes your denominator equal to 0. That's why we're going to put a limit, no, a condition wherein your x is an element of all real numbers here except 0. Because again, 0 will make your denominator equal to 0. Or simply, now, in a simple thing, no, that your x is an element of all real numbers. It can be negative or positive numbers, including 0. But in this case, we neglect 0 as a value of your x. That's why x is not equal to 0. That is, all values can take the variable x except 0. Meaning to say, any values or any negative numbers or negative positive numbers, we can put that as a value of your x variable. Why? Because it can give you a value of denominator which are not equal to 0. That's why we give a condition that x is an element of all real numbers, but x is not equal to 0. Meaning to say, we excluded your x is equal to 0 to the values that we're going to put no in your x variable, because when the denominator becomes 0, your f of x will be undefined. Yes, no, in a fraction, no, in a simple fraction, when your denominator is equal to 0, then the value of that fraction is undefined. So that's a basic concept in mathematics. That's why we really need to make sure that we're going to put the values on your x variable or your domain that can give us a value of denominator which are not equal to 0. So to find the range, so we use the concept f of x is equal to y, so that so we just simply replace your f of x by simply using your y as a replacement of your f of x or your function. So your y now is equal to 2x minus 3 over your x squared. So here, in this case, so we just simply cross multiply this one, your x squared to your y. That's why it's y squared, y multiplied by x squared here is equal to 2x minus 3. So we cross multiply your x squared to your y, then we arrange here your your terms according to their exponent. So we simply first is your leading term now is your y x squared, which has the highest exponent here, and there's an involvement of your x variable. So y x squared minus 2x, why it's 2x? Because we transfer this positive 2x to another side of your equation from positive to negative. That's why it's negative. Now, negative 3, we transfer to another side of your equation. That's why it's positive here. So here, we just simply use the concept of your quadratic formula, wherein your a, there's a quadratic form equation here that ax squared plus bx plus c. So we apply the concept of this one. Your a is your y, your b is equal to negative 2, and your c is equal to positive 3. Now, to get real solutions, we just simply use this part of the quadratic formula b squared minus 4ac greater than or equal to 0. So this formula is called your discriminant. B squared minus 4ac is called discriminant. So again, when you are I mean when you're being asked, what is the what is b squared minus 4ac? So that is a discriminant, from your quadratic uh, formula. And we need to satisfy, that it is greater than or equal to 0. So therefore here, once we substitute these given values here, a is equal to y, b is equal to negative 2, c is equal to negative 3, then this is your assumptions now. That negative 2 square minus 4y3, so we simply take the square of this negative 2, that is 4. We multiply negative 4 by y by 3 and by 3, that is negative 12y greater than or equal to 0. Now, if we transfer this one to another side of your equation, so it becomes positive. So we're going to change the sign of this term, which is negative 12y, going to another side of your equation, and it becomes positive 12y. Then we copy your 4 for the left side of this inequality, I mean, no? Then we divide the entire inequality by 12. So here, it becomes 4 over 12 greater than or equal to 12y over 12. So we can cancel this 12 over 12 because it is equal to 1. 4 and 12 are divisible by 4. So we take this lowest term of this. So 4 divided by 4, it's 4. Then 12 divided by 4, it's 3. That's why it's 1/3 here. Greater than or equal to y. So from this value of y, we can now move to setting, no? Or we can move now for your summary because your y will be your dependent variable, no? To your x, which is your independent variable. Now, we can assign now, no? So in summary, we can say that dx now, no? Your domain is x is an element of all real numbers and x is not equal to 0. Yes, it is, no? Because if your x is equal to 0, it makes sure denominator equal to 0 and it makes sure your function becomes undefined if we put 0 as a value of your variable x. That's why we need to limit, no, that even x is an element of all real numbers, we excluded your 0 as a value that we're going to put as a value of your x variable. And the range is y is the element of all real numbers wherein your y is less than or equal to 1/3. So we just simply put a limit based on the values that we get, no? We got, no, I mean, from the quadratic formula that we use or from the discriminant part of the quadratic formula that we use, no? That's why y is less than or equal to 1/3. So for example number 2, same thing, we're asked to find the domain and range of the rational function. Here, there's a given rational function. Let's check first if this is really a rational function. So we need to check both your numerator and denominator if they are polynomials. So x minus 2 is a linear function, considered as a polynomial. X plus 2 is still a linear function, still considered as a polynomial. Now, we really need to make sure, and we really need to check what value of x will give you a value of denominator which is equal to 0. That's why we're going to equate the denominator equal to 0 for us to find the value of x, which we cannot put on this one, or we exclude, no, to the values of x that we're going to put. So therefore, if we transfer this positive 2 to another side of your equation, it becomes negative 2. Now, so we cannot put negative 2 as the value of x in your denominator because it makes sure denominator equal to 0. So your domain now, your your x is an element of all real numbers where x is not equal to 2. Yes, no? Because we're going to exclude, no, from the values that we're going to put as a value of your x variable here in your denominator and both your numerator and denominator, no, the value of x which is equal to negative 2 because it can provide you a denominator which is equal to 0. That's why your x now can be a value I your x now can be a negative number, a 0, a positive number except negative 2. So We can consider all those values but except -2. That is, all values can take the variable x except -2. So we're going to exclude this -2 to the values of x variable that we're going to put as a value of your domains in the given rational function, because it provides you, no, again, it provides you a value of denominator which is equal to 0. Now, and it becomes, and it makes your f of x, or your function or your rational function, will be undefined. Now, the interval notation can also be written as, so -infinity, -2. So this will be your x, and this will be your y. Union, no? Union to -2, this is your x, and your positive infinity, which is your y. So here, no, negative infinity and -2, union to -2 and -a, meaning to say neg the values of x can be up to -infinity to positive infinity, including 0, but except -2. So here, to find the range, we use f of x is equal to y, so that your y is equal to x or -2 over x plus 2 as your rational function. For you to graph this one, we just simply use the application Desmos. So for you to visualize more, no, your rational function, we can use the application, your mobile application. It can be downloaded, no, to your Play Store, your Google App Store, no. So please download Desmos. Then you just simply input this given rational function here, y is equal to x minus 2 over x plus 2. Then the application will graph your given function. So as we use your Desmos, so this will be the resulting graph for your rational function. For example, number 2. So as you can see here, so there's a line here which is parallel to your x. So it will serve as your asymptote. So at some point here and at some point here, no, your graph will be parallel to this asymptote. Meaning to say that there is no point of intersection between your asymptote and your guide and your graph, I mean, or your curve. In a simple word, no, there is no point of intersection between your asymptotes and your curve, because your asymptote here, this line, no, this line will serve only as a guide for your curve, and there is no such thing as point of intersection between them. Now, moving forward now with the values of y, so in solving this, you just multiply y and the denominator x plus 2, so that it becomes here, no? So we need to cross multiply now, cross multiply, then it becomes x multiplied by y plus 2y is equal to x minus 2. So we're going to factor out, no, your x and -2 to another side of your equation. Since here, your first term here and second term here, there is a variable x attached on them. Same thing with the other side of your equation, which is -2y and -2. We can factor out -2. If we factor out x to your left side, then it becomes x multiplied by y minus 1. And to the right side of your equation, we factor out -2, then -2 multiplied by y plus 1. Now, we simply cross multiply this one, and it becomes the denominator of -2 multiplied by y plus 1. So it becomes x is equal to negative 2 multiplied by y plus 1 over y minus 1. If we're going to equate now, your y minus 1 equal to 0, that is the process, no? We just equate, no? Your denominator equal to 0, and your y now becomes positive 1. Therefore, no? Y is not equal to 1. Otherwise, the denominator is 0. So if y is equal to 1, or your function is equal to 1, then your denominator is equal to 0. So we can conclude, or we can move forward with your summary now, that the range now is y is an element of all real numbers except negative 1. So we can put negative numbers, 0, and positive numbers, but except 1, positive 1. Because positive 1, as a value of your function, the denominator is 0. That is, all values can take the variable y except 1 because the denominator becomes 0 and x will be undefined. So same thing, no, with the process on how we get the value of your domain, no? We just really need to make sure that the value of y now is not equal to we really need to make sure, if for us to find the value of your domain, no? We really need to make sure that the value of y here as a part of your denominator will not provide you a value of your denominator which is equal to 0. Because if we put positive 1 as a value of your I mean 1 minus 1 is 0. Therefore, if y is equal to 1, your x now is undefined because your denominator, in looking for the value of x, it becomes a value over is a 0, or a number over a 0 can provide you an undefined value. That's why we really need to make sure that y, we cannot put positive 1 as a value of your y as a part of your denominator in finding the value of your x here. So for example number 3, we're asked to find the domain of the rational function. Let's check if this is a rational function. If this is really a rational function, your numerator is a quadratic function, your denominator is a quadratic function. Both your numerator and denominator are polynomials. When we say rational function, it's a ratio between your two polynomial. That's why this given is a rational function. So if we want to graph this one, or for us to visualize this given function, what will be the possible graph on this? So we just simply use the application Desmos again by simply using your Desmos. So we just simply uh, input this given rational function to your application, then the application will graph the given function. So the graph of this will look like this, no? So here there is a curve here, and there's a asymptote here as your asymptote, and there's a graph here, and there's a given asymptote again here, no? And there's a graph or a curve here, no? In between your asymptotes. Now, we're asked to find the value of the domain, no? With the concept of this graph, no, by simply looking, we can identify what are the possible domain. But we really need to make sure, no, by simply dealing with your quadratic formula, factoring, or any mathematical processes, no, that we can use for us to check if these values can be a value of your x variable, and it can provide you a value of your rational function which is not equal to 0. So first, we equate the denominator 2x squared plus 7x minus 4 is equal to 0. So by simply factoring, we have 2x minus 1, x plus 4. So here, if for us to check if the way we factor your quadratic equation is correct, we just simply multiply your inner term and multiply your outer term. Then we add them. If the resulting value, no, if we add them and the resulting value is your middle term, then that is correct. So how we factor, no? If we provide a value which is equal to your middle term in your original quadratic equation, then the way we factor is correct. So therefore, no, x is equal to positive 1 half and x is equal to negative 4. So we just simply equate this one to 2x to 0, I mean 2x minus 1 is equal to 0. That's why it becomes x is equal to 1 half. Then here x plus 4 is equal to 0. That's why it becomes negative 4. Now here, no, we're going to exclude, no, or erase or neglect this positive 1 half and negative 4 for all the possible values of your x because it makes your denominator equal to 0. So the domain x now, x is an element of all real numbers. So it can be negative, positive number including 0, but we should put a limit on it wherein x is not equal to negative 4 and positive 1 half. Because based on the process that we use, no, we factor the given quadratic function on your denominator, then we look for the value of x, possible factors, and we're going to neglect or exclude these factors, no, as a value of your x because it can provide you, no, a denominator which is equal to 0. So that is all values can take the variable x except for negative 4 and positive 1 half because the denominator becomes 0 and it provides you a value of f of x that is undefined. So the interval notation can be also be written as d, no? Your negative infinity, x negative 4, union to negative 4 and 1 half, then union to 1 half to positive infinity. Meaning to say your value here of your domain it can be from negative infinity up to positive infinity except negative 4 and 1 half here. So we're going to exclude negative 4 and 1 half as a value of your x from the given real numbers, no? Because it starts from negative infinity up to positive infinity. So we just simply neglect negative 4 and positive 1 half from these possible values of your variable x because it makes your denominator equal to 0 and it can provide you a value of rational function which is undefined. So for example number 4, so we're asked to find the domain and range of a rational function. So here there's a given f of x, and let's check first if both your numerator and denominator are polynomials. So your numerator is a quadratic function and your denominator is a linear function. So therefore, both your numerator and denominator are polynomials. So since we define your rational function as a ratio between your two polynomials, this given is a rational function. So first thing to do is to equate the denominator to 0. So it provides you x is equal to negative 1. That's why the value of this, no, x is equal to negative 1 will be excluded, no, on the values of x or domain that we're going to put, no, as a value of your x variable in both your numerator and denominator because it provides you a value of denominator which is equal to 0 and a value of a function which is undefined. That's why we exclude this negative 1 to the possible values of x that we're going to put as a value of your domain in the given rational function. Now, the domain, x is an element of all real numbers, so it can be negative numbers up to positive numbers including 0, but we need to put a limit where x is not equal to negative 1. we really need to make sure that x is not equal to negative 1. So that is, all values can take the variable x except negative 1, because the denominator becomes 0 and f of x will be undefined. So the interval notation can also be written as your negative infinity to negative 1 union to negative 1 to positive infinity. That's because your value of x can be from negative infinity up to your positive infinity except your negative 1. So we're going to exclude this negative 1 for all the possible values, no, of x that we're going to put as a value of your domain here in the given rational function. So to find the range, we can factor first the numerator. So by simply factoring the numerator, that is x plus 1, x minus 4, we factor the given quadratic function in your numerator, and it becomes x plus 1 multiplied by x minus 4 over x plus 1. So we replace f of x now, that will be equal to y in this portion. So you cannot cancel both x plus 1 of the numerator and denominator, so that what remain is f of x is equal to x minus 4. Then we substitute x is equal to negative 1 to find y. Now, in this case, though, how can we graph this one? So again, by simply using your Desmos, we can easily visualize and graph the given rational function. So in this case, this given function, no, represent a line, no, a line that rises from left to right, meaning to say that your m is a positive slope. As you can see here, no, we can, by simply simplifying this one, we can arrive to this one, no, because we can cancel plus 1, x plus 1 here, no. So if we replace f of x by y, it becomes y is equal to x minus 4. Or we follow the slope-intercept form, y is equal to mx, no, plus b, where your m is equal to a positive here, then 4 is your b, negative 4 is your b, or your y-intercept, I mean. Since your m is a positive value or a positive number, then your line rises from left to right. Now, in finding, no, since there is a given value of x that we're going to exclude for all the possible values, no, then we really need to substitute this negative 1, to our simplified form of your rational function. So we substitute negative 1, it becomes negative 1 minus 4. So we copy this negative 4. So it becomes y is equal to negative 5. Then we're going to exclude, no? Exclude this negative 5 as a value of your y in this case, no? So therefore, the range or your y is an element of all real numbers. So it can be negative numbers, positive number, including 0, but except negative 5. We really need to make sure that your y is not equal to negative 5. In the interval notation, we can rewrite this one, negative infinity, negative 5, union negative 5, positive infinity. So the values can be negative infinity to positive infinity, except negative 5. So we're going to exclude negative 5 for all the possible values of y or range, no, in this given rational function. So for your activity in this video lesson, you need to create your own real-life situations where rational function is applied. So you look for the real-life situations, no, based on your experiences, for example, where we can apply your rational function. For number 2, in a bond paper, no, present the problem from field of application up to presentation. So it can be if you decided to pass your outputs, no, in a through MS Word or PDF form, no, it is okay. You can send this, you can send your output, no, in my through Gmail, or it can be Messenger. Now, for number three, you can use graphing paper, MS Excel, your Desmos. So the most available, convenient, no, in the tree is your Desmos, because you just simply input the given rational function, and the application will automatically graph, no, the given, or the function that you input on this, or anything graphing up to graph the function. So if you have another, no, no, graphing up, then it's fine for me, no. So you can also use calculators to solve the table of values. For number four, your grade will be according to the criteria below. So clarity of presentation 60%, organization is 30%, your applicability to current situation is 10%. So try to look for a situation which is aligned to your COVID, aligned to a pandemic, no, which is COVID-19. So application to current situation. So how can we use, no? How can we apply rational function in the middle of this pandemic? How can we look for a real life situation wherein it is somehow aligned to COVID, no, 19, and then we apply the concept of free rational function. So thanks for watching, like, comment, and share, and subscribe.